Recently, submersible pumps have gained good market shares in both the industrial and domestic sectors due to their high versatility and reliability. They need no priming, they are not prone to the issue of cavitation, and are very efficient. The submersible pump is a centrifugal pump. You can see how the impellers are throwing the water outwards. The impeller blades are the backwards curve type. Here, many of the impellers are connected onto a single shaft, and this shaft is driven by an induction motor. The water enters through the eyes of the impellers, and they are then thrown out radially due to centrifugal action. This way, the water particles gain both kinetic and pressure energy. Now we need to pass this outlet water to the next impeller efficiently. A stationary device called a diffuser is used for this purpose. You can see how the water flowing from the impeller enters the diffuser. The diffuser then deflects the inlet water and makes it ready for the next impeller stage. The next impeller is connected to the outlet of this diffuser. The series of connected impellers multiplies the pressure gain at each stage. This is the reason why submersible pumps produce a huge amount of pressure head. The water, so pumped, passes through an inbuilt non-slam check valve of the submersible pump. The issue of water hammer is effectively reduced by the non-slam check valve, which is a huge issue in high-altitude pumping. Now let's focus on the prime mover of a submersible pump. Generally, an induction motor is used to run the impellers. The power supply to an induction motor is given to the stator, which can be either single-phase or three-phase. The motor produces a lot of heat during operation, and due to this reason, the motor is either water or oil-filled for effective cooling. The continuously circulating coolant jacket around the motor makes sure that the motor never overheats. You can see how a small impeller at the bottom maintains this circulating flow of coolant. The entire impeller motor assembly is immersed in the working fluid. This means that just as with conventional centrifugal pumps, priming is not needed in submersible pumps. Another major issue faced by normal centrifugal pumps is the issue of cavitation. One of the main reasons for this happening is the low pressure on the suction side. In submersible pumps, the water is pushed rather than pulled, and this reduces the chance of a negative pressure head in the system, and thus the issue of cavitation does not occur. The high pressure head, flow rate characteristics, and the ability for it to be immersed completely in the water makes submersible pumps an ideal choice for bore well lifting, firefighting, and oil well lifting. 90% of the oil wells in the world require some kind of artificial lift to achieve an economic flow rate. There is no narrow flow region in the impeller and diffuser section of submersible pumps, and this fact also makes submersible pumps the ideal choice for wastewater pumping and lifting highly viscous fluids.